This is Physics 5, 2006, and question 5a. Complete the following equations for nuclear decay by inserting the appropriate nucleon number in the boxes provided. And so our first equation there is carbon, and it's decaying to nitrogen plus a beta particle, or a 0 minus 1e. So we can see the atomic number there, 6. So minus 1 plus 7 is the number that goes in there, gives you 6, and then 0 plus 14 gives you 14. Second equation shows a decay of uranium to thorium, and it's decaying, giving out an alpha particle. And so 2 plus 90 gives you 92, and 4 plus something gives you 238. So 4 plus 234 gives you 238. Part B. To monitor a patient's thyroid gland, the patient is injected with a radioactive tracer containing 5 by 10 to the 14 atoms of iodine-131. The half-life of iodine-131 is 8 days. Calculate the number of undecayed nuclei of iodine-131 remaining after 29 days. So the first thing that you know there is that the half-life of iodine is 8 days, and therefore we can calculate the decay constant, and the decay constant is 0.693 over the half-life, and if we take that over 8, then we can say that that unit is in days to the minus 1. And we can put this 29 days into our n equals n naught equation without changing it, and use this as well, and the units cancel each other out. So n is equal to n naught e to the minus lambda t. The time is 29 days. So we're calculating the number of undecayed nuclei, so we want n. We know that the radioactive tracer started out with 5 by 10 to the 14, that's our n naught. And it's e to the minus 0.693 over 8 times t. And t, is 29 days, of course. That's times 29. And that's all in a bracket. And whenever you do that calculation, you end up with n is equal to 4.05 by 10 to the 13 nuclei. So the days to the minus 1 and the 29 days cancel each other out. So they actually leave it to 3 significant figures, so 4.05 by 10 to the 13. Next question, calculate the activity of the injected iodine-131 after 29 days. Give your answer in becquerel. Now, the equation we use is A is equal to lambda n, but this time lambda has to be in seconds. And so to change lambda into seconds, it's 0.693. And so over 8 days, 24 hours in a day, 3,600 seconds in an hour. And so that's a calculation to work out n. And so you're going to use 0.693 over 8 by 24 by 3,600. And then you're multiplying by n, and n's the number of undecayed nuclei, and that's 4.05 by 10 to the 13, our answer from above. And you would get error carried forward if you'd made a mistake up in the question above. That comes out as 4.06 by 10 to the 17 becquerel.